I'm CK. Today we've got a kit from Evil Mad Scientist at evilmadscientist.com. It's their Octolively LED kit that's got interactivity. It will react to your hand movement or other movement around it. It's also tileable, even though I only bought one, so we're not going to be able to tile it. So we'll put it together, see what we learn from it, and see how much fun it is. And I hope you enjoy the video. Time to see what's in the bag. Octolively Tileable Digital Interactive LED Soldering Kit. Again, I only bought one of them, so we can't tile it, but we'll see how that might work. Sorry, I got my foot stuck. Evil Mad Scientist, and I got the blue LEDs just because. Let's see if I can open the bag, and I can't, so I'll just cut it open as usual because I'm a barbarian. Take out the piece of paper. Oh, the piece of paper has a circuit board in it. So here's the bill of materials. All that kind of stuff. Circuit board, resistors, IC, switch, phototransistor, infrared phototransistor, chip that I'm not familiar with, LEDs, capacitors, power switch, jack, capacitors, edge connector to make it tileable, 0 ohm jumper, which I always think is bizarre, just use a piece of wire, and an HE Atmel Mega microprocessor pre-programmed, and some aluminum standoffs and a couple of screws. That's pretty straightforward. Let's look at this. This is big. Good for learning. So let's see, it's a good board. All through hole plated. Good quality. Diode, 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 diode. Those are the LEDs, I'm sure. Switch. That looks like power connector, but I don't know why it'd be in the middle of the board like that. This is 5 volts DC in, so I very well could be wrong about that. But 5 volts DC seems kind of low voltage for this. I mean, obviously they know what they're doing. Let's dump out some pieces and see what's up. There's some resistors. Figure they're current limiters on the LEDs. These are the 0 ohm jumpers. In other words, they're like resistors, but they have no resistance, but they're in the same kind of package. Just use a piece of wire. Edge connector. This is the photo sensor diode, I believe, the infrared sensor diode. Infrared sensor device. Cap, edge connector, some more resistors, some more resistors, some more resistors, big old diode, big old LEDs. Let's light one of these up. Actually, I'm going to use my new LED Buddy tool, which I did a couple of videos ago. We'll touch it down here and see what it does. It's blue, 2.7 volts forward voltage, 6 milliamp. I'm running it at 27 volts. Let me drop it down to 5, like it'll be in this installation. 2.7 volts forward voltage, 6 milliamps. 390 ohm series resistor is recommended. This is a very handy device. Again, I did a video on this a little while ago. I'll link it in the description if I remember, which is, quite frankly, unlikely. I always forget. I'm just going to dump the rest of this stuff out. There's the Atmel chip. pre-programmed, even though I guess usually people highlight it. This looks like it's got kind of a pencil mark on it to indicate that it's been programmed. Standoff, decoupling caps, 104s, big beefy switch. This is all good quality parts, by the way. And here are some other LEDs. Let me try these out. Oops, don't drop the thing you just were talking so highly about. Well, that might not be what I think it is. Let me see what that is. These are the smaller so you've got all the infrared sensors, and then this may be the BL-L5131RAB. Let me look that up because I'm not familiar with that. And this could be putting out infrared light. I just can't obviously see it. In fact, the camera may have picked it up when I couldn't. But I'm gonna IRD0, no, BL, yeah, and they're also listed on the board as IRD0 through IRD7, so I'm going to call that infrared diode 0 through infrared diode 7. So BL-L513 IRAB. See what that comes up with. Infrared emitting diodes. Yeah, okay, I was correct. So as this thing interacts with you, these diodes, which I'm going to assume are going down here, are going to be transmitting infrared light, and the detector, which is next to it, is going to, the black detector, which is next to it, is going to pick up the reflections from your hand when you're doing that and cause that visible light LED to light up. Again, I'm speculating. I haven't looked at the build guide or anything else yet, but I'm pretty sure I'm right in that one. And that's about it. Some screws, the pin headers to connect if you want to tile this all together. Looks pretty straightforward to build, and I will go online and get their build guide or whatever. By the way, this is copyright 2011, which is, this is 2023 when I'm recording this. So it's been around, kicking around for a while. So I'll get the soldering iron heated up, I'll get the build guide up on my iPad, and we'll put this thing together. Okay, we've got the build guide up, and as they describe it, it is very picture heavy, and it's true. It's got all kinds of guidance for someone who has not done this before, which is very good, good beginner kit. You can put a power connector here also, but I'll probably just use the screw terminals on the plus 5 volt there because it's just easier for me. So let's start with resistor time. Let's see, what do we got here? We're going to have some 100 ohm resistors. Should have 8. 1, 2, 3, 4, 5, 6, 7, 8. And they will go in R1, let's see, you can also look here, R1 through R8. pull them off the tape. Find R1, which is right over here. We'll do one of them live. Oh, there's a lot. You don't have to put the leads next to the body at all. There's a lot of space, more space than I typically encounter. So I got this one a little cattywampus, because we can probably do 3 millimeters on either side of that resistor. I'm not going to clean it up because I don't care, but just be aware you're not going to bend the leads right up against the body like you do on some other boards. Circuit board is taking solder very well. And that's the first resistor. Now I'm going to do all the rest because there's not much more to say about it, except I will do this one with a little more lead on either side of the resistor and see how that goes. Gosh, that was even too close. I got to leave a lot of resistor. I mean, I'm going to say that's going to be even closer to 4 millimeters than 3. No, 3 millimeters on each side. But I'm going to go ahead and put all the resistors on without commentary, because there's not much else to say about the resistors, and there's a lot of them. So I'll put the playback into fast motion and enjoy a resistor time. And that's all the resistors on. And as you can see, as you're going along building this, they're all grouped because there are 8 visible LEDs, so you're going to have 8 symmetrical little operations. You also notice I didn't get them quite all lined up. It's not for a beauty shot that I put this together, so I didn't try and get them all lined up. Now we're going to put the IC socket on. It's got a little notch right here, and there's a little notch outline on the circuit board. So what I'm going to do is I'm going to put it there. I'm going to lay it, flip it over like so, and I'm going to solder one leg on the socket, and I'm going to flip it back over, make sure everything is flat and it's all good, and it is all good, so I can go ahead and solder the rest of the legs down. All the sockets, pin legs are down, all 40 pins. I'm not going to put the IC in there yet because I'll be working further on the board, so I'm not going to bother with that. I don't want to disturb the IC if I don't need to. Now, next thing, and I don't see it here. Where is it? There it is. So this, which goes over here, is a set of 6 pins that would allow you to program this chip if you want. This is optional because you may never want to program this chip. There's no need for you to. I'm going to put it on just for completeness' sake, because all the information on this board, including the software and so on, is open source. So if you're so inclined, you can dive into it and change things, program it. Now we're going to get a tack switch, a little push button switch. if I can find it. Where is the tact switch? There it is. Little guy here, just a push button with a click. It's not square, it's rectangular. Even though square is a rectangular, it's a non-square rectangle, so you can only put it in the board one way. Pins stick through the board. This has not gone through quite enough. Push it on through so it's flat against the board. Okay, now we're going to do our infrared diode and our infrared receiver. So the blue light emitting diode goes in the things indicated IRD and a number. And the black receptors go in the Q locations. Q is usually reserved for transistors on circuit boards. I don't know why they used it on this. Maybe they didn't have another letter to use. So again, this will transmit some infrared, and it will bounce back from your hand or whatever you put in front of this, and that will go to that infrared photoreceptor and tell it, give it a certain strength, and probably change the visible diodes intensity, or whether they're on or off at all. Now, these are polarized. The long lead on the component indicates the positive leg. The short one is the cathode or negative leg. The negative side also has a flat spot. And the positive lead goes in the square hole on the circuit board. There's also a flat spot on the silk screening, so you can check it that way also. So put all these on. Now, so far I have only soldered one leg of each because I want to make sure these are all flat to the board. And like this one is not. It's raised up a little bit because I was going quickly. So what I'll do is I'll just press on it with my forefinger behind the panel and reheat that one solder connection I made, and it clicks on flat to the board. So we'll do that with all of them, just to make sure they're all snug. I could look at each one of them individually, but I think they're all going to be a little bit off. So I'll just... Now the only thing you need to remember when you're doing this is once you push it on, pull your iron off and let the solder cool before you move your finger. I've more than sometimes have pulled my finger away too quickly, and then the LED or whatever component I'm doing it with moves again, defeating the whole purpose, and I have to go back and do it again. So just let the solder cool a little bit. It doesn't take long, a second. Now I'll just triple check. And yep, they're all down very nicely and completely. Now I'll solder the other legs. And that's all the transmitter and receiver LEDs on the board. And while we're doing LEDs, we may as well put the big light up LEDs on. Same thing. All the diodes of all types are now on the board. Now we're going to put two decoupling caps. These are 104s, 0.1 of a microfarad, or 100 nanofarad. And as you can see, I'm cutting them out of the tape instead of trying to fight them out of the tape. I don't find fighting them out of the tape very comfortable. So I'm looking ahead a little bit at this, because there are parts that are not installed on this kit, so I just want to make sure that I'm doing it right. Again, these three locations are these two capacitors and this XTL. I don't know what that would be. That's not part of this kit. So we're just going to put the two little 100 nano caps in. These condition the power going to the microcontroller a little bit, take some noise out of it, things like that. Very common when you're building semiconductors. I mean, integrated circuit type kits. We'll go ahead and solder down these caps because I just looked ahead a little bit, and we'll want to be doing two things on the next step. So I don't want to, and you'll see why, what I'm talking about here in a second. Basically, because we're going to be installing some parts on the back of the board, so I'll just get those caps out of the way before we do that. So the power switch does not go on the front, it goes on the back. So we'll put it through the back like that. Even though you can also put it on the top if you want, and I think I'm gonna, but you have to have it outside because of the way it's aligned, because of the way the contacts are aligned. You have to have it on. If you're putting it on the back, you're effectively inside that dotted box. Here's the top of the dotted box. But if you're installing it on the front side, which I'm going to do now that I think about it, we'll flip the position around a little bit. Here's my solder. Same as with the socket. Solder it down and take a look, make sure it's all flat, and it is. So we'll do the other pins. That's all ready. Now we're going to put the power jack on the back side. And the way these are oriented, it is near impossible to get it wrong, but you can if you really try. And I'm going to use some slightly thicker solder here, because if you were going to use this with power jack, you want to have a lot of solder in here because it takes the stress. These legs, besides carrying power, also take the strain of holding the power cable to the board. So don't skimp on solder. That's why I go with a little bit thicker solder. I'm not going to be using this power connector right now. I don't know if I fall in love with this device. Maybe I will if I get a bunch more. Now we'll put the electrolytic capacitor on, and that's this guy, and it is polarized also, same as the electrolytic, as the LEDs. Long leg goes in the square. That's not usually the case on most circuit boards. Most circuit boards do not put square holes for capacitors. They do indicate it with, like here, a little plus sign, but most of them do not. mark the circuit board that way. I'm going to stick with this thicker solder just because I happen to have it in my hand. I'll just be careful not to put too much on it. Now they did not give me a screw terminal here for 5 volts in, because typically there'd be a screw terminal. Now the next thing, and I am going to be lazy on this, these are the edge connectors that you would put on so you could connect this edge to edge with another module like this. And that's a very good idea, very neat, but since I only have the one and that's all I believe I'll ever have, I'm not going to do that today. Just burning solder for no reason. These 0 ohm resistors go here and here and here and here, and they are to pass power to the edge connectors. I'm not going, again, since I'm not using the edge connectors, I'm not going to install these. Also, it's kind of cute, the instructions say, for a neater appearance, just use the wire and make a little loop. Yep, I agree with that. Now the next thing along the way, actually they're saying that's the next thing, but I don't think so. They want me to put the microcontroller in, but I'm not going to do that yet because I'm not done with mechanical assembly. I'm going to put these little legs on right now. Not too tight. They don't need to be too tight, because I just don't like to be manipulating the board when I have the processor or other integrated circuit chips installed. Just trying to be a little bit careful about handling integrated circuits. And now, since I don't have, they didn't include a screw terminal, and I've got some of those in stock, but I'm not going to bother. I'm just going to go over here and get some wire. Piece of red wire, piece of black wire. Strip the ends a little bit. That's too much, but that's okay. And we'll just solder them here. That goes in the red wire going in the input positive side. I'm using my locking tweezers to hold the wire in place while I solder it. You should all have a good little set of tweezers. I actually have a video on the channel about tweezers, sets of tweezers you can get, different types of tweezers that you'll find useful when you're doing electronics, whether it be kits like this or guitar amps or whatever. Oops, see? Well, that time I didn't get the tweezers actually on the wire, which makes it kind of useless, doesn't it? Alrighty. I'll twist these a little bit just for fun. Now we'll take the microcontroller, last step, bend the pin slightly inwards against the side of my desk, and now notch, notch, get all the pins in place, look at them all, make sure they're all looking like they're going to go in, give it a good press, it goes in, every pin is in, no pin is bent. So there we are. Now we're ready to power this thing up. I'm going to cycle the cameras before I do that. Now I've turned off my overhead light, even though there's still plenty of light here. As we give this a go, got my little power supply. Can you see that? Kind of there, and you can see I've got it dialed into 4.84 volts, which is close enough to 5. Connecting the red lead, connecting the ground lead, and there we go. As you can see, it's on, and now when I move my hand over these sensors, it comes on really fast and then fades slowly, and we can move it across the whole thing. Actually, I'm going to go ahead and turn off the big overhead light. So now you can see it lights up as you move your hand around. Now pressing this button once changes the behavior of the bulbs. Now they stay on for almost steadily for a while. Let's go to the next pattern. Number 3. Very quick, rapid change. I think they're 8, now we're on 4. Rapid on, and kind of flickery off. We'll go to 5. And you can see the bulb is telling you which mode you're in. It's another flutter. 6. Ooh, rapid on and off. Now we'll go to 7. Ooh, that's a lot of intensity. Now 8. High intensity. Now one other thing you can do is you can hold the button for about 10 seconds, they say. And then you can switch between intensities of the LEDs. And sensitivity of the pickup. I'm going to go back to where I was. So that's it. It's a fun little toy to play with. And again, if you think about putting like 8 by 8 by 8, lights coming on, 8 by 8 by 8 of these against a wall, that could be kind of fun, couldn't it? So that's it. Good kit. The instructions are very good. Theory of operation, they have more on there that you can read about. And a worthwhile kit. And I hope you enjoyed the video.